So now we're going to take a look at the review for test number 4. So problem number 1, we determine if the relation defines y as a one-to-one function of x. So we're going to be using the horizontal line test. So for this first one, that would be a no. We found a horizontal line that passes through more than one point. So we would mark this relation does not define y as a one-to-one function of x. On the second one, any horizontal line passes through at most one point, so this would define y as, boy, that didn't like that. So it should be this bottom one here is dotted in. This relation defines y as a one-to-one function of x. So here we're doing the same thing. So remember, we got first see if it's a function, and then see is one-to-one. So all the x values should be different, and all the y values should be different. And if so, then it is a one-to-one function. Each x is going to one specific y value, and each y value is coming from one specific x value. So this relation does define y as a one-to-one function. For 2b, that's not the case here. So even though it's a function, it's not one-to-one because I got the same y value coming from different x values. So I'm going to mark that one there. All right, let's turn the page. The graph of the function is given. I want to graph the inverse. All right, so I'm going to start picking some points. So this is the point 0, 1. So I'm looking for a graph with 1, 0. So that would be a no to A, no to B, could be C. That's okay because that goes through 1, 0. Could be D. Yep, that's all right. E would be a no, and F would be a no. So now I am down to C or D, and they almost look the same. So we're going to have to pick another point. So let's pick this point up here. So I'm looking at -2, 4. Switch the x and y coordinates to be 4, -2. So I'm looking for 4, -2. That's 4, -4. That's not going to work. 4, -4. So C doesn't work. Notice D does. 4, -2. Bingo. D is the correct answer. So just pick some points, switch the x and y coordinates, eliminate your graph. So let's take a look at number 4. Here we want to graph the function, write the domain, range, and interval notation. So I'm going to do -3, -2, -1, 0, 1. I didn't leave myself enough room. So let me move the table over. You got a little more space here. So I'm going to do -3, -2, -1, 0, 1, 2, and 3. And just remember, we can do that quickly on our calculator to generate those points. Turn it on. Table. We got 3 of the x in here. Okay. Well, I thought we would just type it in. So I'm going to start at -3. And I'm just going to copy down the values. 1/27, 1/9, 1/3, 1, 3, 9, and 27. Now, I got kind of a limited scale here, so I've got to pick the points I can actually graph. So I'm going to do 0, 1, 1, 3, 2 9s off the graph. So -1, 1/3, -2, 1/9, -3, 1/27. So that's what my graph's going to look like. And this is going to be very similar, except it's a 1/4, so it's going to be reflected around. But again, if you want to do that table really quickly, I can do parentheses 1/4, close parentheses, caret x, enter. And I'm going to start this at -3 again. And then I could just write down the values. So I'll make a little table over here. So this was 64, 16, 4, 1, 1/4, 1/16, 1/64. So I'm just kind of get those very quickly off my table. So, and if you have this on the test, it's going to probably be multiple choice. So, because we know what the graphing is like in ALEKS. So I have 0, 1, -1, 4, -2/16 off the graph, 1, 1/4, 2, 1/16, 3, 1/64. So just applying those points, and then just going to draw it in. All right, for both of these, the domain here is all real numbers because it's an exponential function. The range here for both of them is going to be the positive real numbers. So this would be from -infinity to infinity for both of these. There's no shifting here, so the range doesn't change. 0 to infinity. Suppose that 14,500 is invested at 5.15% interest for 8 years compounded quarterly. What's the resulting value? So if we read from our formula sheet, A equals P plus 1 plus R over N raised to the NT. My P here is this 14,500. My R here, I'll have to write that as a decimal, 0.0515. My N, well, it's compounded quarterly, so that means N equals 4. And we're going for 8 years, so T is going to be 8. And now I'm just going to stick that in the calculator and see which of these answers is the closest to that. So let me do second quit. 14,500, 1 plus, fraction key 0.0515 over 4, right arrow, close it, caret key 4 parentheses 8. So I'm looking for $21,835.10. That looks like it's answer choice number 2 there in that first column. So I'm going to mark that one. Okay, this is almost the same thing, but notice the word compounded continuously. So I'm using A equals PE to the RT for this one. So let's plug in. We have 19,500. E. I'm going to write this as a decimal, so 0.0465. And my time here is 6 years. So now I'm going to put that into the calculator. So 19,500. Second, ln 0.0465, and my t was 6. Going to hit my enter key. So I'm looking for $25,775.24. So it looks like it's the last choice here. So I'm going to mark that one. All right, so this next one, write the equation in exponential form. And, okay, so what you need to do is rewrite this. My base here is b. My power is c. And my argument is a. So it's got to be a equals b to c. Be careful when you're doing this in ALEKS. If they're using uppercase letters, make sure you use uppercase. If they're using lower cases, use lowercase. Make sure your cases match. All right, problem number 8. We're going to graph. And again, what I like to do is get the exponential function and then switch the x and y coordinates. So I'm going to be picking my y values here. So I want to pick -3, -2, -1, 0, 1, 2, and 3. My x values here are going to be 4 to the y. 4 to -3 is 1 over 64. 4 to -2 is 1 over 16. 4 -1 is 1/4. That's going to be 1, 4, 16, 64. So I'm going to plot 1, 0, 4, 1. Anything else is far off. And then I want to do 1/4 -1, 1/16 -2, so on and so forth. So I'm going to draw my graph as best I can. So my graph's going to look like that. Now the domain here is going to be 0 to infinity. My range here is going to be all real numbers because we don't have any shifting going on here. And we want to do the same thing in part B. So let's get this going. Again, I'm going to be picking my y values, -3, -2, -1, 0, 1, 2, and 3. And I'm going to get my x values. That's 1/3 to the y. So if I raise that, it's going to be 27, 9, 3, 1, 1/3, 1/9, 1 over 27. So again, I'm just doing the exponential and switching the x and y coordinates. So I'm going to start with 0, 1, 0. Then we have 3, -1. 9, -2 is off the graph. 1/3, 1 is here. 1/9, 2. 1/27, 3, so on and so forth. So my graph's going to go through these points here, extend out that way, and then go through here. Now my domain and range should be the same as the last one. So domain's all positive real numbers. Range is all real numbers.